Hi, welcome to video 11F. We're going to continue with some probability rules. So this is probability rules and definitions part 2. We've looked at some. It would be nice if every pair of events were disjoint, but in reality, lots of events are not disjoint. And so we had that addition rule when our events were disjoint, when they both couldn't occur at the same time. But we need an addition rule for what if our events can occur at the same time. So the addition rule for non-disjoint events, and actually this works for any events, whether they're disjoint or not, but if we want to know the probability that event A or event B occurs, we can take and add the probability of event A plus the probability of event B. But when our events are not disjoint, we then need to subtract off the probability that both A and B occur. And we're calling this the addition rule for non-disjoint events. It turns out it works for disjoint events because when your events are disjoint, A and B can't both happen. This ends up being 0, and we have our addition rule for disjoint events. So this will actually work whether your events are disjoint or not. So let's look at some examples and see this addition rule in action. Okay, so all Cecil College graduates have to take one college-level math course for their degree. Most students take pre-calculus or statistics. The probability that a student has taken pre-calculus is 0.23. The probability a student has taken statistics is 0.71. We also know that about 15% of our graduates have taken both statistics and pre-calculus. So first, let's draw a Venn diagram of this situation. So remember, inside your rectangle, this is sort of everyone's of interest in the problem. And this problem talks about Cecil College graduates. So this rectangle contains all Cecil College graduates. And we have some students that have taken statistics. A lot of students take statistics. So I'll make a fairly large circle here. These are the students that have had statistics. Some students have taken pre-calculus and some have taken both. When I draw my circle for pre-calculus, I need to make sure it intersects with the statistics circle. So I'll put pre-calculus over here, not quite as large of a circle. And now I'd like to fill in these probabilities. And just to make this a little easier to read, I'm going to make this intersection just a little bit larger. Okay, 71%, or the likelihood of taking statistics is 0.71. The probability of this entire circle has to be 0.71. I don't want to put 0.71 right here. If I did, I forgot to compensate for the students that are here. So always start in the middle when you can. These are the students that took both courses. 15% took both as a probability. That's 0.15, so that goes in the middle. When we then want to figure out what's the probability that a student takes statistics, what's left here, these are the students that take statistics only. They did not take pre-calculus. And so if you take the probability of taking statistics, 0.71, and subtract off the probability that those students also took pre-calculus, that leaves a probability that a student only took statistics of being 0.056. And now when you look at that entire statistics circle, that has a probability of 0.71. We need to do the same thing over here. The entire pre-calculus circle has to add up to a probability of 0.23. If you take 0.23, subtract off 0.15, we're left with a probability here of 0.08. 8% of the students took pre-calculus only, no statistics. And then we also have the students out here. You have to take a college level math, so they took something else. They took finite math, or they transferred something in, or took calculus maybe, they placed right into calculus, but they did not take statistics, did not take pre-calc. So, these students might have taken finite, calculus, transferred in. It was definitely not stats, not pre-calc. And how are we going to find out what the probability is of being one of those students? Again, use one of your probability rules. The sum of all the probabilities has to be 1. So if you take 1 and subtract off the probabilities that we already have, we'll get 1 minus 0.79. And so therefore there's a 0.21 probability that you took something besides statistics and pre-calculus. And so that's what the Venn diagram would look like for this problem. All right, in part B, we're going to go ahead and use that addition rule for non-disjoint events, taking statistics and taking pre-calc. Those are not disjoint. You could be a person who has taken both of them while you were here at Cecil. So let's look at part B. Give the probability that a student has taken pre-calculus or statistics. When you see or, it's always implied that you might have taken pre-calc, or you might have taken statistics, or you might have taken both. It includes pretty much everybody in one of these two circles here. So if we use that addition rule, probability that you took statistics or pre-calc, first let me do this with the Venn diagram, then I'll come back and use the rule. Using the Venn diagram, that's the students here, here, and here. We could just simply sum up those 3 probabilities. So this is the likelihood a student took statistics, or took pre-calc, or took both. And if you sum those up, the probability is 0.79 or 79% chance. Let me do this one over again, but this time I'm going to use that addition rule. So I'm going to erase the diagram. All right, that addition rule said this is the probability of taking stats plus the probability that a student took pre-calc. And then we have to subtract off the probability that a student took both. All right, now if you go back up to the middle of this page, it says that the probability that a student takes statistics is 0.71. The likelihood a student takes pre-calculus is 0.23. And if you look at your Venn diagram, we can't simply add those two, because if you add those two, the 15% of the students that took both, that 15% in the middle, they get counted here, and they get counted again here. And we only want to count them one time, so we're going to subtract off the 15% of students that took both courses. And when you do that, we'll end up with the same answer. So in that addition rule for events that are not disjoint, or actually the general addition rule, the reason why you're subtracting off the likelihood of both events is because those students got counted here, they got counted again here. We only want to count them one time, so we make sure we subtract them off here at the end. All right, let's go on and look at one more example. Okay, a randomly selected Cecil student has a 74% probability of having only a Facebook account, a 6% probability of having only a Twitter account, and a 4% probability of having neither. Draw a Venn diagram. All right, so this is Cecil students. So my rectangle will contain all Cecil students. A lot of students have a Facebook account. So if this is Facebook, Some students have a Twitter account. Now it doesn't say here, and we'll be able to figure this out, but my guess is that some of you have Facebook and Twitter, right? You could have both. So more than likely these events are not disjoint. So I'm going to have them cross over here. And we'll put Twitter here. Now usually you start in the middle if you can. So if we were given the likelihood of having a Facebook account and a Twitter account, we'd start here. We don't have that. So what if I start at the bottom? There's a 4% probability of having neither. They're the people outside your circles. So the probability of being outside the circle is 0.04. Now let's see what we have. There's a 6% probability of having only a Twitter account. These are the students here that have only a Twitter account. They do not have a Facebook account. So this probability right here is 0.06. There's a 74% probability of having only a Facebook account. So if we cover up that Twitter circle, the probability of just being a part of this part of the Facebook circle here is 0.074. And this is what we don't know this time. And so just like before, we can use the fact that the sum of all the probabilities should be 1 to figure out what is the likelihood of having both. If we end up with 0, then our events are disjoint. I don't think they'll be disjoint. So let's take 1 minus and add up what we do have. This adds up to 0.84, so 1 minus 0.84 leaves us with a probability of 0.16, a 16% chance that you have both. Again, I should have drawn that intersection a little bit larger. So this is what our Venn diagram will look like for this one. Now let's answer a series of questions. What's the probability a student has a Facebook account? Not only a Facebook account, but has a Facebook account. That's this entire circle right here. And so the likelihood that a student has a Facebook account, we need to take those that only have a Facebook account and add the students that have Facebook and Twitter. And in total, the probability of having a Facebook account is 0.90, or 90% of students have a Facebook account. Let's do the same thing with Twitter. What's the probability a student has a Twitter account? That's this circle right here, so we're going to add these two probabilities. So 16% have Facebook and Twitter. 6% have only a Twitter account. If we add those two up, the probability is 0.22, or 22% of students have a Twitter account. All right, next one. How about Facebook or Twitter? These are the students that have a Facebook account or a Twitter account or both. The easiest way to do this one is probably straight from the Venn diagram. It's the people that have Facebook or Twitter or both. We'll just simply sum up those three numbers. When we do that, we get a probability of 0.96, or 96% of students have Facebook or Twitter. You could have also used the addition rule. If you did that, the probability of having a Facebook account was 0.9. The probability of having a Twitter account was 0.22. You can't simply take 0.9 and add 0.22. For one thing, the sum is more than 1. Can't have a probability bigger than 1. So at the end there, we'd have to subtract off 0.16 because they would have gotten counted here and then here again. So you get the same answer if you use that addition rule. I'll abbreviate this here. But the probability of having a Facebook account was 0.90. Probability of having a Twitter account was 0.22. We'd have to make sure then we subtract off the likelihood of having both, and if you do that, we should be right back at the same answer we got when we used our Venn diagram. So you could do that one either way. Venn diagram is probably the easiest. All right, two more that sort of will lead us into the next video. What's the chance a student has Facebook if she has Twitter? So we know this about the student. This student has a Twitter account. And if we know that she has a Twitter account, what's the likelihood that she has Facebook? So we want to know the likelihood that she has Facebook. If we know, given that she has a Twitter account, I'm going to draw this line here, Twitter. This is the probability that we're trying to find. This is what we already know about this student. We'll see this syntax in the next video. This is called a conditional probability. What you know always comes after the line. And let's think about this. If we know that the person has a Twitter account, we're really only looking at these students right here. They've got a Twitter account. So that's sort of what our total is going to be out of. And out of the 22% that have a Twitter account, what's the likelihood a person has a Facebook account? Well, 16% out of the 22% do. So we'll compute this by finding the probability that a student has both of these accounts divided by the likelihood that they have a Twitter account, since that's the one that's known. Whatever condition is known, that will always go down in the bottom. So the likelihood a student has a Twitter account, again, was 0.22, and the likelihood of having both was 0.16. And when we divide those, we get a probability of about 0.727, almost a 73% chance, if we know you have a Twitter account, that you also happen to have Facebook. So starting to introduce the concept of a conditional probability. One more. What's the chance a student has Twitter if she has Facebook? This time, this is the opposite of the problem we did before. This time we want to know the likelihood that they have a Twitter account if we know they have a Facebook account. So what we know about the student here is different from the last problem. So what's the chance that a student has a Twitter account? This is the likelihood we want to find if we know they have a Facebook account. This is the condition that we know. And again, we'll take the probability of both of these divided by the probability of the condition that we know. We know the student has a Facebook account, so we're only looking at these students right here. So out of those students, the Facebook circle accounted for 90% of the students. Out of those 90%, what percentage have both Twitter and Facebook? So this time, if you take 0.16 divided by 0.9, we get the likelihood is 0.178. And so if you stay tuned for the next video, we'll solidify this concept of what's called a conditional probability, finding the likelihood of something. If you know something, there's a condition about the person that is known. So that's it for this one.